Okay. So I'm starting from the very scratch, okay, from the Hive, right? Okay, what is fundamentals of the Hive, okay? And it is a very important topic, ecosystem component of Hadoop, okay? So Hadoop ecosystem component is Hive, okay? Hive is a Hadoop ecosystem component. Hive is Hadoop ecosystem component. And the main purpose of Hive is for as a data warehouse tool, right? It is used as a SQL data warehouse tool. We'll see some data warehousing tools in cloud as well, right? There is a Redshift is there in AWS. Azure, we have a SQL data warehouse tool. And in GCP, we have BigQuery. So those are the same like data warehousing tool. And Hive is the part of the Hadoop ecosystem, okay? So when we start Hive, so first we need to understand the basic fundamentals of the Hive. Okay. So Hive, the initial background of Hive is like basically started by the Facebook. Okay. So long back, Facebook has started Hive and it is donated, right? It is like given to the Apache community, okay, later on. So Hive is basically a distributed framework, right, on the Hadoop cluster, and it is processing the data as a large amount of data. And Hive is completely based on the Hadoop, right? Because the prerequisite of Hive is Hadoop file system, okay? Because it is processing the data only on Hadoop file system. So like it's a SQL query tool, but when we are giving our SQL query, so it will be converted into the MapReduce. Okay, so at the end, it is converted into the MapReduce, and then it's running a MapReduce. So that is the reason we should have a very good understanding about the MapReduce, how MapReduce works, because Hive internally creating the MapReduce job. Okay, so when we are writing a select queries. Like insert update queries. So these queries are converted into the MapReduce job. Okay. So when we come to the Hive, okay. So Hive is a data warehousing tool, and but we don't need to learn the Java Hadoop APIs because internally Hive is generating the MapReduce. Okay. We don't need to write MapReduce for the Hive. Okay. So it is done by. So if we talk about Hive is a data warehouse, Hive is a ETL, Hive is a SQL query tool, and Hive is providing like custom mappers and reducers inbuilt, right? And we can write our own custom, like Hive UDF is a very strong feature, like user defined function. You can write your custom function, right? You can write your custom UDF function you can write for the Hive. Okay. Like if I say the three types of UDFs are there: UDF, UDAF, and UDTF. Okay. User defined function, user defined aggregate function, and user defined table function. Okay. So you'll see that those are the like powerful. This is a powerful feature of the Hive. So Hive is in the different scenarios where we can use Hive, okay? Because Pig is completely outdated because Pig is nobody's using. Pig is also analytics tool, and that is initially introduced by the Yahoo, okay? But nowadays Pig is not being used, right? Pig is using the Pig Latin script, and now if I say Hive is giving a more productivity, right? In terms of writing SQLs, we can write more powerful SQL queries and we can get the data. Okay. So if we compare Pig and Hive, Pig is a procedural kind of language and Hive is a declarative. And Pig is using the ETL operators and like load, dump, like kind of operator. But SQL is a completely declarative. It's like a SQL queries. So it's a declarative kind of language. Okay. So if we see more differences in the Pig and Hive, so these are the everything is there in the Pig as well, but the scripting language is different. Here is a Pig Latin and it's a SQL like language. Okay, but the operators, everything, whatever is in the SQL, same are there in the Pig. Okay, nowadays Pig is completely outdated. Pig is outdated now because the reason is like Pig has not improved, right? Like performance wise, is the Hive is better performance than the Pig, because pig is again converting into the Hadoop MapReduce job. Okay, Hive is also, but pig we have to write little bit more code as compared to Hive. If I say if I'm writing a one SQL query count star in Hive, so I need to write 3 to 4 lines of code in pig. Okay, so productivity wise, I'm saying like MapReduce is very less than pig, and then Hive is having a high productivity because Hive we are writing a one line of SQL queries, right? So it is more like a productivity wise, it's better, right? And in Hive architecture, if you look at Hive has a different component. In Hive architecture, Hive is providing the wave UI. Hive is providing command line interface that is called HiveQL prompt, and Hive can have like a different interfaces like Cloudera has provided Hue, and other tools are there, right? So we can provide some dviewer. Okay, dviewer is also one user interface tools. So those tools can interact with the Hive. Okay, so Hive is using internally one Metastore DB, and this Metastore DB is a separate DB which is storing the metadata about the Hive tables. Okay, so in Hive architecture, we have Derby. So Derby is a Metastore DB, and the Derby is used as a meta information about the Hive table. And actual data is stored in Hive on SDFS. Okay, so the storage part of the Hive table is Hadoop file system, and there is a between a one processing engine, right, which is taking a queries from the Hive client user interface or command line interface and execute the queries. And basically this execution engine is converting into the MapReduce job. And this MapReduce job is finally run and then giving a result to the end user. Okay. So Metastore DB is always being interacted by the like uh, this QL, right? HiveQL engine, right? Because the processing the data. So whatever the data types and column names, all those information about the table, it is stored in the Metastore. So Metastore DB, we can configure our own Metastore DB like MySQL Oracle, or by default, whenever you are installing Hive, you will get by default Derby. Okay, so Derby is a by default given as a Metastore DB. Okay, so there are the different key component like Hive shell is there, Hive Metastore there, execution in there, Hive driver is there, compiler is there, one parser is also there. So compiler is compiling the Hive query, parser is parsing the Hive queries, right? Because before compilation, the parser comes in picture, and driver is the main interaction, right, from the end user, right, which is providing the classes, right, library classes, right, so that it can compile your queries, right? And execution engine is basically converting into the MapReduce job. Okay, so these are the core component. And how many types of Metastore DBs are there? So embedded Metastore DB is there, local is there. There are different Metastore DBs are there. So embedded Metastore DB, local Metastore DB, and remote Metastore DB. So embedded Metastore DB is by default Derby, and it is provided by the Hive itself. Okay, so you can see here the Derby is a Metastore DB, and that is inbuilt in the Hive itself. Okay, and it's a very small database, like just 10 MB database size, and this is provided as a SQL database. So all the Metastore information is stored in this Derby. Okay, so just remember, right, Hive is having a default Metastore DB is Derby, but sometimes you say, okay, you want to configure your own SQL database. So we can change hivesite.xml, and there we can change the database parameter and add MySQL as a Metastore DB. Okay. So local Metastore DB is again in the same machine, same JVM, right? You have MySQL DB, and that is acting as a Metastore DB. So that is called local Metastore. And the remote Metastore out of your JVM and another JVM, another machine, your MySQL DB is there, okay, as a Metastore DB. So that is called the remote Metastore. So these are the three types are there. So by default, we have embedded Metastore. But if you want to use local or remote, so we have to configure it. Okay, so we can configure it in our configuration file, and whatever database we want to use, we can configure in our Hive site.xml. Okay, so that I will show you where you can change the parameter. So limitations of Hive. So latency of the Hive query is generally very high, sometimes in the minute, because you can think about it, because Hive is basically generating a MapReduce. So MapReduce job is not that much faster. Okay, so there is a Impala. Impala is a substitute is there, and Impala is a in-memory management, just like a Spark. It is processing a query inside the memory itself. Okay, so it is not converting into the MapReduce. So Impala is like whatever your database tables are there in Hive, same you can access through Impala. So Impala is like a tool, right? And that is provided. It is not a part of Hadoop ecosystem. Actually, Cloudera has provided Impala. We can use Impala as a query processing engine. Okay. And does not offer the real-time queries, right? Suppose you want to interact as a real-time query dashboard, right? So you cannot do with the Hive. So in the cloud, there are Athena. Athena is a tool in the AWS cloud, right? That is an interactive dashboard query tool. So Hive is not a real-time, okay, interactive dashboard query. Not designed for the online transaction processing. It is only for batch processing. Okay. So online transaction processing, we have SQL databases, right? We have MySQL, Oracle, SQL Server. So these are the databases we use for online transaction processing. So Hive is for OLAP. So what is the difference between the OLAP and OLTP? So OLAP is an online analytical processing and used for the batch processing data. So OLAP operations are analytical processing. Okay. And generally the data warehousing tool. So data warehousing tools have the concept, right? If you heard about like fact table, dimensions, fact dimensions. So these are the types of tables, right? And further, we have the different types of schemas are there, right? We have a star schema, a snowflake schema, galaxy schema. Okay. So a star is the one fact and multiple dimensions are there. Snowflake is multiple fact can be there and dimensions are divided into the sub dimensions. Okay, I'll provide the notes of the data warehousing. This is the data modeling side, architecture designs things. Okay, there you will find this OLAP, OLTP. Okay, what are the different types of schemas are there, SCD, or those things when you will be further writing the writing queries, right? You are doing in Hive, and then you will go more in details. Like SCD is a slowly changing dimension. So slowly changing dimensions, like you are not always reading the data. You are sometimes updating, inserting, deleting data. For that purpose, we use SCD. So there are the different types are there, type 1, type 2. So type 1 is just directly overriding the data in your existing table. Type 2, you are maintaining the history version. So here you are maintaining history version. So that is basically the type 2. Okay. So we'll see that. And online transaction processing like SQL DBs. So we know there are many SQL databases are there. All these are the online transaction processing, right? MySQL, Oracle, SQL Server, DB2, right? All these databases are the online transaction process. Okay, so high level, we should know what is the difference, and then we should know further what is like further data modeling things. Okay, so far good. Like, okay, so how we can define the difference between the Hive versus RDMS? Okay, so if I say what is the difference between the Hive and the traditional DBs, right? Like OLTP and OLAP. Okay. So the very first difference comes here is schema on read and schema on write. Okay. So Hive is a schema on read. Schema on read. So Hive is a schema on read, and schema on write. Schema on write is SQL DB. So SQL DB is a schema on write. Okay. So why we call Hive is a schema on read, and why we call schema on read SQL DBs like MySQL and Oracle. Okay. So the one difference you will see MySQL and SQL Server. So schema on read, like your schema, what do you understand the schema? Okay, because when you are understanding Hive, schema is like defining the data types, right? You are defining the data types for your table columns, right? For table columns. Okay. So that is your schema, right? So if I say if your schema, right, their data types, schema or data types are validated before writing data into table. Okay. So that is there in schema on write. Okay, in SQL DBs. SQL DBs are very strict, very strict. They will not allow to write your data if your data types are not matching of your data. Okay, so they will not allow to write the data. That is the reason it is called schema on write. So that is the reason if you are writing large data, insert queries, large data like insert queries. Generally, you write a data with the insert queries. So insert queries, large data like large insert queries, you are writing. It will take more time. It will take more time because it is validating schema. So performance is not good, right? Performance is not good while you are inserting data. But while reading data, it is faster because SQL DBs have a lot of features are there, like indexing is there, right? Indexing is making it data retrieval faster. But we will go another one is if your schema is not validated before writing data into table, this is called schema on read. So schema is validated at the time of reading. So schema is validating at the time of reading data from table, reading data from in Hive. So if I say if 100,000 record, if I'm inserting in Hive 100,000 records, inserting Hive is faster than in SQL DB. Okay, because this is just dumping the data. So Hive is just dumping data without validation into table. Okay, so it will be taking a fractions of second and write the data. And the other hand, like if you are trying the same thing in the SQL, it will be taking hour or minute. Okay, so that is the reason our insertion data is really very faster. But schema on read when you're writing some select query in Hive, and that time your data type is not valid. Data type is not valid. Okay, then it will be giving you null values, or it will give you the data type cast error. Okay, so data casting error we will get. Okay, so this is a good thing about the Hive, right? Because most of the times we are writing data into Hive tables, right, from the external source, right, ingesting data. So ingestion process sometimes is taking more time. So then after that, you will not get the time for the querying the data. So querying the data on the table when you can do when the data is there in the table, and data insertion of data is taking more time, that will be right, like delaying your querying the data. Okay, so data validation happens. So this is the concept of a schema on read and schema on write. So Hive is a schema on read, and SQL DBs are the schema on write. Okay, so this is the concept. So initially Hive has not provided the update and delete operations, but the newer version of the Hive, right? If when you're talking the Hive latest version, right? Hive 3.x, right? So Hive 3.1.3, this version we will use. So this one version, or even 2.x version onward, they allowed update and delete operation. Generally, what was the intention initially not to update the table in Hive? Because Hadoop file system data is meant for, right, reading data, right? Most of the times we are not updating new data you can insert, but updating data, that will be give more challenging issues, right? Like because you are updating the existing file, So your previous data can be overridden, right? So in that case, we have to use some CDC process, right? Change data capture or SCD type process, okay? But the later version, like Hive become more efficient, and there is a asset transaction concept came in Hive, asset transaction manager, and that has allowed in Hive, same like a SQL databases, we can do update and delete operation. So same like asset, but this is not still the default operation. So whenever you are doing any update and delete operation in Hive table, so there are the different ways are there. So you have to enable this transaction manager property. You need to enable transaction manager property, and some other like enforce bucketing property. So we have to enable these property, then only we can allow update and delete operation. Okay, so next thing is now when we see another concept is in Hive is serialization, deserialization. Okay, so there is a concept of Saturday. So Hive is having the Saturday concept. Saturday is basically very important concept in the Hive, serialization and deserialization. The purpose of this one, because whenever we are ingesting data, so sometimes our data is not a text file format data. Because suppose comma delimited data is there, right? ID, name, age, okay, city. So this is the comma delimited data we can do. This is the default text file format data. But suppose my data is a JSON file, XML file, my file is a Parquet, Avro. These are the all different types of format Hive support. Okay. So if this type of file, and sometimes it's the regex format also, like log files are there. You have seen logs files data. Okay. If this kind of files data you want to insert, we cannot direct straightforward we can write. So we need to use some Saturday, and Saturday is basically Java classes are provided by Hive. Java class is provided by Hive um, in some jar that we have to use in our Hive table. Like so, those classes we have to define in our create table statement. I will show that. So when you write create table, my table, and you say define the field, then you say uh, you can say JSON Saturday. Suppose you are going to use a JSON Saturday is the class provided by the Hive for inserting the JSON data. Suppose you are going to write a XML data, so XML Saturday is there. If you want to write like a Parquet, so it's stored as a Parquet. It's stored as a Parquet Saturday is there. Parquet. Okay, it's stored as Parquet. So different these file format data we can write. Okay, so I will show that how to use Saturday, and the another concept in the Hive is a UDF. Okay, so UDF is a user defined function, and different types of UDFs like custom UDF. This is so there are the two types of UDFs like built-in UDF. So built-in UDF we know, right? Every SQL databases like we have the built-in UDF, like string functions are there, number functions are there, date functions are there. So different categories of the functions are there. But if I don't want to use the built-in, so another one like we can create my own custom function UDF I can create. So I can create my own requirement. I can create a UDF, and there the UDF is the one category, and UDAF, user defined aggregate function, like sum, average, min, max. Okay, so I can customize these kind of aggregate functions. And third one is a UDTF, user defined table function, like explode function is there, which is converting is array values into the number of rows. Okay, so if I say one student has marks, like student ID, and marks array is there. Okay, so I have a marks array is there like 23, 56, 78, like three subjects marks is there. So I want to say like student S1 has marks 23, S1 has marks 56, and S1 has the marks 78. Okay, so I want to convert. So one more thing is Hive is supporting complex data type. So you already know there are two different data types are there. So data types are defined in two different ways. One is a primitive data type. The primitive data type category Primitive data type is like int is there, string is there, long is there, double is there. Those we know all the programming has the data type. So text type is called here string. Okay. But another data type is there that is called complex data type. Complex data type is a combination of the primitive to become a complex. So there are three categories is there. Three types are there. One is an array, one is a struct, and one is a map. Okay. So array is the same data type. Suppose I want to define the student subject marks. So all will be integer, right? So same data type, right, is having called array. A struct is like a combination of different data types is a struct combination. Suppose address, I'm taking an example, combination of different data type. So if I take an example of address type, so address can have city, state, okay, and zip code. Zip code is an integer, okay. So these are the combinations are there. And the third complex type is map. So map is a very special type, key and value type. Suppose I say some key is associated value. So I say one department ID and department name, okay. So every department ID is associated with the department name, like a key and value is there, okay. So this kind of requirement is there, I will go for map. So we have to define the tables, right? A SQL tables will create by using this complex data type, okay. Okay, so that I will come. And Hive is having, Hive is start first from the top level in the hierarchy is the databases. So database, we know it's a collection of tables. It's a collections of tables. For the next component is in Hive in the objects, like these are called the objects, right? Like one type of object is database, right? Same in the SQL. SQL is also having the same hierarchy because SQL is having like databases, SQL DBs have database is on top, and that is a collection of tables. And table is collection of rows, right? Collection of rows and fields, and we called it records and column, records and columns. Okay. So tables and table has the field. Okay. And field is making combination of fields making rows or record. Okay. This is the basic three the objects are there, okay, and there are many more objects are there, like we will create a indexes are there, views are there, indexing, okay, view, okay, procedure, function, right? So but procedure function label is not there, function is there but procedure is not there, okay. So function, we know user defined function, so that is kind of function, okay. So functions we can create, okay. The purpose of the function is providing a reusability. Once you create a function, and that function can be reused multiple times. So that's the purpose of the function. Okay. Okay. So is it clear so far? So when we come to the table and what is the schema? Okay. So schema is like we can define a database schema. So every database, like we have tables and tables has the schema. So database has the tables and table has, so every table schema defines schema, and schema is basically nothing but a data types of columns, okay. That is a schema, okay. Okay, so when we come to the another thing in the table, like table label, we have two things, okay. So first we look at two types of category of the tables, two types of category of tables, like internal table and external table. That is a very much important thing. External table and internal table. Okay. So like all these tables are storing data where in Hadoop file system, right? So internal table is a managed table. So actually in Hive, there is a user Hive warehouse directory is there. Hive warehouse, user Hive warehouse directory. And this user Hive warehouse directory, which is storing data for managed table, managed table, like table which is creating without any external keyword. Okay, so there are the two ways we can create table, one without external keyword and one with external keyword. So when you say create table and I say my table and you define the table. And another way is create external table. So when you say external table, so there is again two things are there. You can define the location or you cannot define. If you don't specify the location, okay, so by default, right, if you don't define the location, it will go to the warehouse. So what is the warehouse directory? User Hive warehouse, and your folder will be created. So inside the user Hive warehouse, and inside this your database folder will be there. Suppose my database name is mydb.db. db is the extension for as a database slash my table. So whenever you are creating any table, it will go by default in this location. Okay, and in this my table here, your data will be stored as a file. Okay, so when you do internal table, you are not specifying external keyword, but this will go to the this warehouse directory. Okay, and if you are creating an external table without location, if you are creating an external table without location, that will be going also the same warehouse directory, the location same. But suppose you have specified the location keyword, okay, location, and you're giving your custom location. Suppose you are saying my location is ext slash my table. So this is some directory you created, like Hadoop directory you can create. So this is a home directory you created, and this home directory, this is a root directory you created some directory in Hadoop file system, and inside this you created some table directory. Inside that your data will go. So here your data will be stored. Okay, so here will be data will be stored in the external location. So that is basically called the external table with location. Okay. Now another difference is when you are dropping the internal table, okay, your data and schema, okay, both will be deleted. Okay, both will be deleted. Okay, so it is not secure, right? Because if someone is dropping the table, your schema means your create table syntax, right? So your table schema will be deleted as well. Okay, so we will be very careful when we are internal table, but generally companies, they are not providing a direct access to the warehouse directory because it is a very risky. So anyone can drop the tables by mistake, and it is a completely role based access. Okay, and another one is the external table is not not risk is there, because if you drop external table, drop external table, so only data will be remain there. Schema is deleted. Schema will be deleted. Only schema will be deleted. So what is the advantage? Like, okay, schema is deleted. Okay, I have a schema command, right? I have a create table syntax, right? So I can recreate table again. Okay, and whatever data is on the place, and it will be reassociated. So it is just making it your data with the schema. Like it's basically dropping a table means it is deleting your schema. It is detaching your data from your schema. Okay, so when you create a table again with the same schema and same location, then your data will be attached. Okay, so this way we can see the internal and external table. Okay, I will show this all practical things, and the next thing is we will see partitioning and bucketing. Okay, so this is very powerful concept in the Hive. Generally, we don't want to scan the whole table. We want to avoid the scanning the whole table. We go for partitioning, and bucketing is on other hand is creating a output file within a partition for better performance. Okay, so if you guys have not installed the Hive, you can install Hive. Okay, I have not installed because of it right now. Only Hadoop is there in my system. Okay, so if I want to install Hive, so first of all, the Java is the prerequisite. The Java should be there. Okay, and so in the instruction wise, first of all, we should have Java. Okay, so Java should be, we already done Hadoop, so we have already Java. So next thing is we have to go to official page and take the Hive 1.3 right, from where we can get the downloading folder. So this is Hive 1.3. So this particular tar file I will download. Okay. So I'm telling from the scratch only. So how to install Hive. So I will go to my software folders, and here is already my Hadoop is there. So I'm installing. So wget command I will use. I paste here. Okay. So I will extract this one and I will set the home path. So I will go step by step. Okay. So now it is downloading. The first step is, in this document, we have to download the Hive. We go to the release page, go to here. So this is the older version. And I downloaded this wget command, extracted it, then I will xgf command. So I will extract this one to the extract the folder. Okay. So once it's done, I will extract it, and then I will set my home path. So this path I have to set it in my home in the bash rc. And after that, I will be I will be creating a temp directory and warehouse directory. So I was talking already this directory, right? So this directory we have to create before, right? Before using the Hive, we have to create this directory on Hadoop file system and give the write and execute permission also. Okay. So here I'm giving a chmod g plus w. So group level, I'm giving a write permission. Okay. So I'm giving a write permission. So that is needed. Otherwise, you can't write the data in your warehouse directory. Okay. So the permission is important. You have to give the permission. So you have to give the permission to this. So the group level permission I'm giving. Okay. So first permission is a user. Second one is a group. Okay. So we have to add the plus W. Another permission I'm adding, write permission I'm adding. Okay. So that permission I'm adding. And one more directory I have to create a temp that is internally used by the Hive. So these two directories we have to create and give the permission. Okay. So, so this is, we are going to set up Hive, and make sure your Hadoop is keep running, your Hadoop file system. Okay. That is approx 330, 40 MB. Okay. 311. Okay. So now if I check here, I got, so tar xgf, and I will give Apache Hive. I will rename this folder because it's a too large folder name, right? 3.1.3 bin. So I will rename Apache Hive bin to Apache Hive 3.1.3. Okay. And I will remove this tar file because it's no use for us. We already has 3.3.3 bin. Okay. So remove this. Okay. Now you can see your Apache Hive 3.1.3 folder is there. And if you go inside this CD, so here, this is your all the Hive binaries. This is a Hive binaries. You can see here example JDBC, lib, conf, bin. Okay. So if you go to CD bin, you can see what are the shell scripts are there. Okay. So Metastore there, Hive server 2 is there. All these are there. Okay. So now I take this path and I need to change my bash RC. So I will copy this. I will open the nano bash RC. So I have to open the nano bash RC here in the home directory. So here I will go. So mine is already Hadoop is there. So I paste it. So what are the modification I have to do here? First of all, this folder name is 3.1.3. And this is not my home directory. My home directory is my username slash softwares. Okay. And one more thing is here. Okay, all good, all good. Slash home slash. Okay. So now I will save it this one. Control X, Shift Y, Enter. And
You have
so
to remove the double quotes.
what? Uh, which double code? The double code on the
Oh, there should be a
not a
double
problem.
quote from
Not a
if
problem.
it's
Yeah,
okay.
it's fine. See, either double code you give or without double code, it's not a. It's like a string. It is taking as a string. Okay. So now my path is set. Okay. So my path is set. This one is done. So this thing we don't need to do anything. This export is saying like in hive config.sh. So in the hive home, right? The CD, if you go softwares, and there is a hive Apache hive. So here is the conf folder CD conf. So these are the different config templates are there. So one is Hive env ss template. So this one we have to rename Hive env ss template to Hive env.sh, Hive env.sh. And another one is we have to change Hive default XML, Hive default to Hive site.xml. Okay. So this is standard that we have to change. Okay. So these two changes. And it is saying export Hadoop. We are doing Hive config. So Hive config is nothing but your Hive env.sh. So they are saying, but it is not required. I tested without that. So now next is we have to create a Hadoop directory. So just create a directory. Okay. So next we have to give the permission. Okay. So mine is TMP already created. Okay, fine. Okay, so that's not a, but user Hive will not be there because I have not installed before. So this one, okay, next is I have to give permission. Okay, let's see what is the permission now. When you create any directory, what permission comes? Okay, so Hadoop DFS, SDFS, DFS minus ls and slash user slash hive slash warehouse. So, okay, we check one level up. So if you see here, RWX user has full permission, but for group, RX is there. Execute permission is there, read permission is there, but W is not there. So that we are doing, right? So like any other user, right, who is writing data, they can write because the group is now super group. But suppose some Hadoop group is there, which is writing data. So that can write the data. So that is the reason we are giving the right permission group to write. So we are adding, now if I check it again, now I will see RWX, RWX. Okay, so RWX, RWX, right? in a group, write permission. And next thing is like this already I did change, right? Hive default XML to hive site.xml. I changed. Now, next thing is they are saying, so by default is Metastore server is deep derby, right? And warehouse directory is already configured. I don't need to do anything. Just I have to initialize my Derby database. So this is a command. So I will run this command. So, so it is giving a error like line number this 3215. There is some special character is there. So this is giving us some character code. Okay. So I need to modify the hive site.xml. So so home Arvind softwares, and here is my hive folder and hive site.xml conf, and this is my hive site.xml. Oh yeah, this is change, right? Hive site.xml. Okay, so I will open in simple notepad. So here line number is not coming. But I can see here line number 197. This is 3215. 38.
I think you can control Z 3215. I think.
3215. So when I reach to this line, so this is a special character. So if I remove this character, save the file. Now I will run my same command again. So one more error will come after this. When we start Hive, then one error will come, that is a IOTMDIR. Okay, so that is not there in the website, because that error you will get it. Okay, here it is not mentioned, that error, because they started Hive and they are getting the Hive. But if you do it, it will come. So right now I kept it open because I have to search Hive this IOTMDIR word, and then I have to delete everywhere, right? So this IOTMDIR is coming. So I have to copy this one, Java IOTMDIR. So I have to copy this and I have to search. So all the places wherever this is coming, I have to delete. So total 6 are there. So I have to delete very carefully because I have to delete complete end-to-end property, like starting to end property. Okay. So this is starting property and end property. Okay. Next, I have to find. So this is a one more. Okay. Then next, this is one more. This is next. Actually, these two are at the same place. And this is the last. This is the last. And now you search, there is no. Okay, now save this file. And now you run your Hive. This is done. So now you will get a Hive shell. So you will get a Hive prompt, and there you can now start the Hive commands. So by default, Hive is giving a default DB. That is by default database is given by the Hive. But I can create my own database by using a create database command, and I can create my own database. Okay. So first practical we will do with the internal and external table. So when I see here, show databases, very, very basic first SQL command, like show databases. So default is coming as a initial database, okay? And any database you want to use, there is a use command is there, right? Suppose I want to get the SQL query, I want to run a database, you have to use command. First, I will create my database, create database, and I just give the name testing and show databases. Now testing is coming, use testing and show tables. Probably right now there will be no tables because I just created database. So now I can start the creating tables. So my database is created. So first thing I need to create a database before starting to create further tables, we need to create database. Okay. So how to create an internal and external tables? Okay. So if you want to create an internal and external table, so create table command, and then we can create an internal and external table. Okay. Let me just find the nodes. It will be very quick, right? So create table things are there. So suppose my database is already created. I'm now creating a table as a patient table. So Hive shell, I'm creating a patient table. So I will be simply just creating a table, create table patient, and ID, name, and drug, and gender, and total amount. These are the four columns. And in Hive, we are using row format delimited and field terminated by comma. So row format delimited, every line will be like terminated by a new line character automatically, and field terminated by comma. So whatever data I'm going to store in the table, right, like a backend data will be there, that will be comma delimited data. The comma, like table columns will be comma delimited. Okay, and but when you look at the data as a table, you will see the tabular data, right? Generally, we see in the SQL database, same you will see. Now this table is an internal table. You can see this table is not using any external keyword. So if I want to see the syntax of this table, create table syntax, there is a command show create table patient. Okay. When you do this, you can see your create table syntax. And this create table syntax is giving the by default location is going to the warehouse. So user hive warehouse testing.db, and patient is the table name directory. So when you copy this, and suppose you want to check in this location, what is there? So one thing is, any Hadoop command also you can run here. Just use exclamation mark, use Hadoop fs minus ls command. Okay, even Unix command also you can run. Just simply exclamation and say ls and semicolon. So you can see in this particular current directory where my Hive is started, it is showing me this ls. Okay, so if you want to see ls for, like, suppose you slash home slash like that, you can give for any directory you can give, you can check that one also. Slash home software directories, like I want to see ls. So you can see this is my, so simple Linux command you can run, or Hadoop command you can run. You want to run Hadoop fs minus ls of Hadoop directory. So Hadoop directory is your directory where your Hive table data is stored. So if I copy my this user Hive warehouse directory, okay, so this directory is my Hadoop directory. So right now nothing will be there because this table is empty table. Just I created a table. If I see select star from patient, so I will see there is no data, right? Because table is empty. So now how many ways I can write the data? So there are two ways. One is load data local command you can use in the Hive shell, or you can use Hadoop fs minus put command and write the file. Okay. So first we go to the data set for this particular. Or we can prepare the data. So this is, they are saying some directory. Okay. So what we can do, I want to prepare the data. Okay. So Abhi, right now I'm here, and I will create a directory Hive test. Okay, cd Hive test. And now I'm preparing some cat greater than file. I say internal.txt, and I want to write a data. So if I want to write a data, I know the column name. So patient ID is an integer. Okay, I take a one. Okay, patient name, X I'm taking, drug, that is test, any name, and gender male. And I say total amount is 50. This is just sample data I'm creating. Test 2, email, 3, 4, 5. Just 3 record I'm creating. Test 3, control D. Okay, so my file is there. And this file, now what I will do here, I will use the command load data local in path. So what local in path means? Local means I want to read the data from local file system. So the path I will give, that will be a local directory, like /home /Arvind hive test /internal.txt. Okay. So complete path I'm giving the location where my data is there into table is a keyword and table name. My table name is a patient. Okay. So this is a simple command. If your data is in Hadoop file system, so you will not use this local keyword. You will use load data in path. That's the difference. Okay. So when you are loading data from local to Hadoop file system in Hive table, or Hadoop to Hadoop files, Hadoop directory to Hadoop table, Hive table. Okay. So now I'm going to load data. So data loading, I told you very fast, right? Because this is very only 3 record, but I'm saying even 50,000 record, if I'm going to load, it will be fraction second, it will load. Again. So now I can verify my table, select star from patient. Now I will see, I'm able to see the 5 records are coming. Its header is not coming. If you want to header, you have to set some property for CLI header. So header will come. Okay. So this select star from table. If I want to run this query, select count star. So what should be result? If I writing the select count star patient. So it is running a map reduce job. So even this count star is taking time, right? Because reading data, I told you it is slower, right, in Hive, because it is doing schema on read, and it is generally writing a map reduce job. So if you see here, it is converting into map reduce job. So mapper and reducer, right? And it is getting the data. Okay. So Hive is meant for the large amount of data, not for small data. We are doing this like queries. Okay. Very, very large amount of data. So here is a map 0, reduce 0, and 100 is like map and reduce is 0. And again, 100 is converted into. So total 3 count is coming. So my SQL query is giving the result 3, right? So basically, I'm just writing a query, but internally, what is happening? So your query is going, the query parser is there, compiler is there, query execution engine is converting into map reduce is converting into logical plan, physical plan, and then finally you are getting the data from your Hadoop file system. Okay. So your data is stored in Hadoop file system as a file. Okay. Your data is stored. So now we do one experiment. Like this is the internal table, right? And show create table, I have showed you the. So now we check the data, how the data is stored in the Hadoop file system. So let's see Hadoop fs minus ls slash user slash hive slash warehouse slash testing.db slash patient is a directory. Okay. So inside this patient directory, your file is there. Okay. So now you can see as it is, the file is copied. So if you can see here, whatever load data local in path command, what it actually exactly doing in the backend, you are doing load data local in path, but what it is doing internally. Can you tell me? What do you understand? Like by this, whatever I'm showing to you here, what is the meaning of this display? what is the meaning of this? What exactly the load data local in path command is doing internally?
MapReduce code it is on.
No, MapReduce is load data local in path, that is doing, but I'm saying
Just copying.
like exactly
We are loading the data in,
what?
we are loading the data into the table.
Loading your data into table. Okay, that is there. Okay, actually, I wanted to know this file name is the same or not, whatever your local. So it has just used the put command, na, right? You use load
copy of
data
what.
local in path. You use load data local in path, but internally what it did, it just took file and use command to write into Hadoop file system in a particular your table directory, right? Correct. And that table, like once the file come in your Hadoop file system, your table directory, and data automatically populated, right? So that MapReduce, what it did exactly, your file picked up from your local file system and copied the exactly the same file in your Hadoop. So if I do the same job myself, because whatever is doing, I can do myself also, na, put command I can use. Okay, if I drop this table, I show you. So I want to show you this thing, like whether you use load data local in path command or you copy file manually in Hadoop file system by using the put command, both are same thing. Okay. So either way you can do, both are same, because whatever is Hive is doing, same thing I can do manually, right? But the real way is the practical way or correct way is use load data local in path command. So drop table, and I'm going to drop this table patient. So what will happen? My table and data both will be deleted. Now, if I do select table command, there is no table, right? So table is deleted. So schema is gone. Now I should verify the data. Now this is my table directory. So this should be also coming now, not found. Because when the data is deleted, when the table is deleted, definitely the table folder will be deleted. So now everything is gone. Okay. Now I have to create a table from the scratch. Okay. So now I'm creating a same table again. Same table again. Now you see table has come. Now this folder will be there, but empty because data is lost, right? Again, I have to write the data. Okay. The table folder is there. There is no error, right? But if I do select count star, or if I see select star from table, I will see no data because still I have not loaded. Now I will use the Hadoop command to put the data. I will use Hadoop fs minus put my directory where my data is there, slash home, slash my username, hive test, slash internal.txt, and I'm putting in the this location, user hive warehouse patient, and testing.db slash patient. One single command I run. Now I check the select star from table. My data is coming same, right? So here I showed you either you use load data local path command or you can put command, both are same. So what Hadoop Hive is doing, same thing we did manually, right? So your data will automatically populated once the file comes with your same data type, whatever you defined in your table schema. If you see DSC and say patient, you can say this data types. Okay. So if your data type is not mismatching, your data will be coming null, right? Your data, it will not giving error. It will make it your data null. Okay. So that will be, so describe command is there. One more command is there, describe extended patient, describe extended. It is giving you more detailed schema. More detailed schema means like you can see more information about your table, right? All these information, when the table is created, who created, all those information. But simple describe is just giving you the basic schema. Now I'm going to create a same table name. I cannot create an external table. Okay. I have to change the table name. So I have just changed the table name as a external, and same thing I'm giving But here I'm adding a one more like a property here, location. And this location I will give my Hadoop location. Okay. But I have to change it because I cannot use as it is, because this location is not my location. So I have to change my Hadoop location. So whatever location you do, you don't need to create. It will automatically create. So suppose I'm giving a data ext and I'm giving patient exe. So this location will be created, and then your data you can write later. Okay. So this table, when you create table, your location will be automatically created for you. Okay. Okay. My external table is created. Now I want to verify whether this table, this location is created or not. So I will go data ext patient ext. Okay. It will be empty. So same job if I do here, that put command or load data local command, it will be same or not. So whether the table is an internal or external, it doesn't matter. Data loading is not a matter. You can use the same process. So if you want to load data local path command, so you will use a load data local path command. Just change the table name. So load data local path command. Just change the table name here. So the data is same, right? Because I know the table schema is same. I'm not creating a separate one more file. Okay. So file I can use same. Okay. Just I'm loading the data in my patient ext table. Okay. My data is loaded. Now I want to check my select select patient ext. So same data will come because the column names, schema, everything is same. So you seen that by using the load data local path command, we have loaded data into the external table. But this data, where is this data? This data is in an external location. Again, we see the external location. So this time, this external location, my file will be coming. As it is, the file is copied. Can you see the same file is there, internal.txt? Same thing I will do for external table. But before that, I will drop table and I'll show to you. This time the schema will be deleted, but data will not be deleted. So drop table, and now I'm giving a table name patient ext. My table is dropped. Now I do select star from patient exe. I will get the error. Table not found. Okay. But still, if I see my data location, my file is not deleted. My file is still be there. Right? My file is still there. My data is not deleted. If you want to remove the file, you have to remove manually by using Hadoop fs rm command. Okay. So Hadoop fs minus rm and then data slash. So generally what we say, if you have drop the table, and again if I recreate the table, if I recreate the same table again, so my data and table will be reassociated. Data is on the same location, just I'm recreating the table. Now if I see select star from patient ext, can you see the data is again associated? Okay. Again, I'm dropping table. I will show through put command. So drop table patient ext. Okay. And I have to remove manually the file because the file is not deleted. So Hadoop fs minus rm slash data ext slash patient ext slash internal.txt. Okay. I have to remove manually the file. Okay. So I'm going to create a table from the scratch, and I want to show you how we can write the data using the put command. Okay. So I'm creating this table again. So because I'm following all the steps in the sequence so that you can practice the same thing, like same way you can practice each and every scenario. Okay. So this is the last scenario for the external table. We are going to test like how to use put command, because already we've seen for internal table, but external table we are going to check. So I created table, and now this time I will use Hadoop fs put command to write the data, and my location is slash home slash hive test slash internal.txt, and that is my Hadoop location. Same way like I did for internal table, patient.txt, just I copy the file. Okay. So once the file is copied in the location, in the external table location, now I can see table select star from patient.txt. Okay. So this is the internal table and external table practical, right? How to use internal and external table when we drop table and when we are, so how can it work? Okay. Okay, so next thing we will see the partition concept, right? How to use partition and what is the purpose of the partitioning and bucketing. Okay. Okay, let's take 10-minute break and then I'll start. Yeah, guys. Hello. So I'm sharing the screen. So next, first we understand what is the partitioning and bucketing and why we need partitioning. Okay. Okay. So when we are writing any SQL query in Hive, right, we write a select star from table. Okay. And suppose I'm giving some where clause city equal to some xyz city. Okay. And suppose I have for this particular city, I have a very less record. Okay. So if I say just 100,000 records are there. And for this particular total records, and I have for this city XYG, I have just few records. Just assume that 10 records are there. So if I'm writing this query, what will happen, right? If I'm writing just select star from table where city equal to XYG, and I'm going to retrieve only 10 record out of 100,000 record. So it will take time, right? Because it's scanning the whole data and the column wise, it will find where the city equal to XYG is matching, and it will be giving me the record. So we can avoid the scanning the whole table. We can avoid scanning whole table. Okay. And instead of that, there is a concept of partitioning. So partitioning is in Hive is a logical division of the data. So logical division of the data based on some partition column values. Okay. And we will fetch the data, directly from the partition. So it will be very quick, like whatever time you assume, like this in record. So it will be directly get this data quickly because this partition is already prepared. Okay. So we need to create a one partition table. So partition table is nothing but as usual your normal table. Just you will add one partition by clause, partition by, and you will give the column name with data, so name and data type. So suppose in this case, right, create table, my table, and you are saying partition by city column, and city column is a string type. Okay. So like this, you will create table. So partition table can be internal table, external table. It doesn't, right? It's a different thing. What could be is there. Okay. But partition table can be any type of table, can be partition table, but just we have to use partition by clause. Okay. So the main purpose of the partitioning is basically improving the performance of your select queries. So your scanning of that. So when your data size is too large and you are searching a small data, right, in the large data set, so it will take definitely more time. So that time you can reduce, okay, by using the partitioning. So bucketing, I'll explain bucketing also on the same time now so that you will get a difference. So bucketing is basically further in the partition. Okay, bucketing can be without partition also there, but here I am taking a case of partitioning, and further in the partition, we can distribute the output file, physical output file, distribute the data of partition. So generally in the partition, in case of partition, only one single file will be there. Okay. So in case of partition, only one single partition file will be there. Okay. So suppose one partition has 10,000 record. Okay. So all 10,000 record are one single file will be there. So what is again, if I want to improve, I say suppose in this 10,000 record, I want to find a particular ID. So you will be again scanning this 10,000 record, right, within a partition. So what we can do, we can create physical output file, equally distributed file. Suppose I am creating a 10 bucket. So the 10 bucket means when partitioning of the data, further in the partition, we can distribute the data of partition into physical output file of equal data, physical output files into equal size of the data, equal size of data into number of files. Those are called buckets. Okay. So if your data is divided, and there is a distributed, there is a clustered by key issue. There is a clustered by clause is there. So clustered by, you can define your clustered by column. Suppose my clustered by column is employee ID, and I say integer. So this clustered by column should be unique column, and partition columns could have repeated data. So high cardinality and low cardinality, right? So always, right? Okay. So suppose where the data is more in the column, that should be always the partition column. If the data is not repeated, right? So that column should be always the bucketing column, bucketed column. So when I say the physical output file into equal size of the data into number of files, buckets, and there is a clustered by key used in create table to divide data into buckets. And there is a hashing technique is there. Hashing is a technique used to distribute data into number of bucket. So suppose if I say this 10,000 record, 10 bucket is there, so 1 to 1,000 record. Okay, all will go to 1 to 1,000 record. IDs will go to the first bucket. Okay, and again like this 1,001 record, not 10,000, 1,001 1,001 to 2,000 will go to another bucket. Okay, 2,000 will go to the another bucket. Okay, so just I'm assuming it, the IDs are going into the first bucket, second bucket, like this, the data is distributing. So like total, like 9,001 to 10,000. So the data is distributing in 10 bucket. Suppose my ID, which I want to use in my where clause, I say select star from EMP where city is XYZ. So partition is XYZ, and ID, I say EMP ID, I want to search in that partition. I want to search, suppose some 5,000, 6,001 ID. So what it will do when it will see the partition column and bucketing column. So bucketing column, it will find out the hashing technique, which bucket that record is stored. It will find, okay, sixth bucket, this record is there. In the sixth bucket, it will record is there, only 1,000 record it will scan. It will not scan the all 10,000 record. It will scan only 1,000 record, and it will find the record quickly. Okay, for the same city. Okay, because this all 10,000 record for the same city, right? Same partition. But again, the records are distributed into the buckets, and each bucket has the number of record. So it will identify, okay, this particular ID is going into the one particular bucket, and it will scan and it will get it. Okay. So bucketing is further improvement of the partitioning. Okay. So let's see with the example. So just assume it, I have some student data is there, like sections, right? So every section, right, I say section A, section B. Okay. So I'm creating a one table, and this is an internal table. Okay. And I'm creating this table, create table student 1, 2, and it has 3 columns: student name, father name, and percentage. So always whatever the partition column we are using, that should not be logical. That is a logical column. It should not be the part of table. Okay. So logically, it will be distributing the data. Okay. It is not created physically the different table. The table is only one, but logically the data is distributed based on this partition column. Okay. The section. So there are 2 types of partitioning is there. So this is the example of static partition, and dynamic partition is when the data is loaded dynamically. So static partition is a manual partition where the data you need to load into the partition table. Can you see this is the partition table? The student 12 underscore ST80, this is a partition table. And in this partition table, we have the clause partition by. Okay. So you are loading the data from where? You are loading the data from the files. You already know, right? Files, we are loading the data, right? Load data local in path command. So same command I'm using, load data local in path command, and I'm loading the data into partition table. And then I'm querying the partition table. I'm querying the partition table based on the partition column values. Okay. So that's my goal. But here why I'm calling it static partition? But this static partition from file to table, because my data is in the file and I'm loading the data manually from files to table. Another case of the static partition, I will tell you, table to table. Suppose you don't have multiple file, you have a one single table is there for this all data, these 4 record. So suppose my data is in the some source table. This is my source table where my data is present, but this table is not a partition table. And another table is my partition table is there. This partition table is static partition table. And this when I load this data into my source table, all 4 record, I will load that data from source table to partition table. So I'm using here insert into command. So whenever you are loading data from file to table, you use load data command. And when you are loading the data from table to table, then you are using insert into table command. So insert into, you are giving source table, insert into target table, your partition table, and telling about the select command for your source table. Okay, both the partitioning I will show. First you understand how to create a static partition, static table partition, and load the data into partition table. So right now there is no need of source table. Okay, because we are loading data into partition table using the file. Okay, so I'm going to create this. This table is created, and now I'm creating a sample data. Okay, so one file is a section underscore a. So I'm copying this data, section underscore a. So here cat command section underscore a. I'm not giving extension. So I'm writing the data. Control D. Same like I will go cat section B, section underscore B. And this data is sample data. So what are the fields are there? Student name, father name, and percentage. Okay. So Control D. So 2 files are there, section A, section B. Now I'm doing the load data local in path. So I have to change this location. My is this Hive test, because my input file is there in the Hive test directory. Okay, section underscore A, section underscore B into table, same table, because I have not changed the table name. So I will load the data one by one. So static means manually loading the data in each partition. I will tell the disadvantage of the static partition, because if the number of partitions are more, then it is a problem. What is happening? Oh, this single code thing. Oh, first of all, I'm running in the terminal. Okay. I have to run here. Okay. So this is saying /home. Okay. The problem is whenever you copy in this text document, the single code from the internet, right? So that need to be changed. Okay. So loading data into, this is the one partition is added. So if you do select star from your table, so only one partition data you got it. Okay. So now I will add the second partition. I will change the, okay, here is fine. Here is single code, looks good. No files matching. Hive dash section B, section. What is the file name? I kept it. Section. Okay, I put it a wrong name. So that is my mistake. That is the reason it's saying file not found. Oh. So actually I missed the section C. SETION. SETION_B. Okay, so second one is loaded. If you do select star from, so you will get the both the partition. Okay, but this is not our purpose. Our purpose is to check individual partition so that we can see performance. Okay, so this is the one partition A, section A. So this is coming from partition. Section B. So this is very like a less data, so you will not see very good performance. But when the data is more, when you are loading more data, so here is a static way you loaded data into partition table. Now I have to create a one source table, and that source table has the section column, because I have to tell my input file for my this source table. When I load the data, I have to tell my all this section column name. So I'm creating a, again here is a problem, single quote. Okay, my table is created, and this input file I create, and load the data into source table. So cat section dot section. So I load the data, control D. Now here is in the source table, I'm loading the data, load data local in path. So here is a Hive test, my location, and the file name is a section, and table name is a source table. So load data local in path command I'm going to run in the Hive shell. So table not found. What is the table I created? Student source 1 2 student underscore. Okay, it's a wrong file name. Student source 1 2. Okay, now my source is populated. Now if I see select star from student underscore source 1 2 table, so I'm getting my source. Now I have to load the data into my partition table. So another partition table I'm creating. I don't want to mess up. Same partition table. There is no change in the partition table. So just I'm creating a new table name student 1 2 stat partition, just for writing data from table to table. So I created. Now I'm doing insert into table command. How many times? So static partition, whether you do file to table or file to file, in both the cases, you have to load the data those many number of times you have the partition. That is a drawback. Okay, suppose your partitions are 100, so 100 times you will write this query. If you have partition 4000, so 4000 times you will write this insert query. So that thing we will avoid in dynamic partition. So dynamic partition will be giving you the dynamically loaded data automatically by only single insert query. Only one single insert query will load into 4000 partition, 10,000 partitions. So then you will see the advantage of the dynamic partition. Okay, so but static partition also we can use, but the scenario is when you have a less partitions. So now student 1 2 stat part section A. So here we need to specify when you are doing table to table, insert into table, partition and section equal to A, and select student name, father name, percentage. But you don't need to give the column name section here, but column name you tell here in the where clause. If you don't tell in the where clause, what will happen? This entire data will go to one partition. Again, entire data will go into one partition. That will be wrong. So you don't need to miss here the partition and don't miss here the partition. Here you have to give the partition name. You want to make sure, right, whatever data you are taking it from the source is going to the one partition, this particular partition. And here you are making sure the same thing. So 2 times you are giving. So that is your table name is the student 1 2 student underscore 1 2. Okay, so this is your A and B. Okay, so 2 times we'll run the command. Okay, so this will be running map reduce job because it's a table to table. Once this is completed, then you will run the second one. Okay, so this is the one completed. And for the second partition, you have to run command. So what is the problem is coming here? Can anyone tell what is the problem in this query? Something like a column names are mismatched, right? So whatever your source, you are giving 4 columns and your target has 3 columns, right? Because the fourth column is a logical column, right? So I told here, right, when last time you run the query, so you were not giving the section in the source because section will be in the where clause, not in the, so you don't need to give the section here. Section no need to give, only just keep it 3 columns, which are the main columns, and the logical column should be as a where clause to get the data and write the data to the partition table. Okay. So you have to specify the partition clause here and specify which partition column and which value. And partition can be nested also, right? You can have partition by clause, you have 2 columns, right? Suppose you say section and inside the section further subsection. Okay, so like this nested partition can be there, like country has the city, country has the state can have city. Okay, or you can have year has the month has the date, right? So multiple sub-nested partition. So now if we do select query, so the select query we have the same, there is no difference. Okay, so if I'm going to check my partition table, select star from, and my partition table name is this one, and here where clause section equal to a. So only the way in static, these two are the different ways, but end result is same. Okay, the final goal and you are getting the data partition, that is the same. Only difference is you have done file to file and a static partition you did table to table. Okay.
What happens if it's a case sensitive, smaller A or smaller B? It will be one more bucket.
See here, searching you are saying or loading you are saying. First, what you are saying. Here you are
Both.
small a like this.
Yeah.
See, it will not find the data, right? Generally in the SQLs also, right? Because it's a case sensitive thing. Whatever is coming in the single code, it's a case sensitive. So it will not find, no, because it is matching exactly the case sensitive, right? This is SQL thing, right? It's
Okay.
not, there is nothing related to Hive. It's just a normal common scenario. Like even in the SQL also, if you are not giving an exact value, so you have to use some in case sensitive things like you can use, okay, or upper lower case you can do, then you can make it like case sensitive. Okay, because right now you have to make it lowercase. So if you want to match it with a, make it this lower function. Okay, I think lower function is there, or what is there, some function. See, now it's coming. So this way you can do. Okay, so that you need to know, right? Your column data maybe case sensitive is there in your column, so accordingly you use the string functions. Okay, you use. Okay. Okay, so when this is the static partition, now dynamic partition we are going. So dynamic partition, the creation of the table, there is no difference. It's the same like create table, you are creating a dynamic partition, row format delimited and field terminated by, and partition column we are defining. Okay, so I'm creating a one more table, a dynamic partition table. Okay, just partition table. We call it name as a dynamic or static, it doesn't matter. The table name, I'm just creating a table. Okay. After that, only one insert source table I can use the same because dynamic partition is using table to table. Okay, there is no file. Okay, because I'm loading the data dynamically, so one file I cannot load. Okay, I will load multiple data. Okay, multiple partition data from a single table I can load into the partition table. So my source table should have already different partition data should be there, and that is already there. If we see student source 1 2, select star from student underscore source 1 2. So I have a 2 section data in my table. So just I'm going to run one single command. insert into table partition, but now here column and value is not coming. Only column name is coming. Okay. And select, I'm giving a source, and even I'm not giving the where clause because I don't need to do one by one insert, right? I'm already saying the dynamic partition will automatically load the data into all the partition in the partition table. It will automatically identify. It will check in the section column. Suppose in your source data has A and B. So it will create two partition. When it will find, okay, three different values are there. So it will create three. So you don't need to worry about like how many partitions will be there. It will automatically come. So now I will be running a one single command, this insert into table command. But you know, dynamic partition is not a default partition. When you try this command, it will give you the error, and it is saying dynamic partition strict mode required at least one static partition. So it is saying either make your this insert query as a static partition query, right? Section equal to A or B, something like this you go. Or if you want to use dynamic partition, so definitely you have to set this property. At least this property you have to set, then only you can apply the dynamic partition. If you use this property, there is a one more property is there, Hive execution dynamic partition true. But this property is mandatory. Now, if you run the same command, it will work now because your dynamic partition is enabled. Okay. So dynamic partition is not default. It's by default is a disable. Okay. So now you see both the partition A and B will be automatically created in a one single command. Okay. So advantage of the dynamic partition, see it is created. Now you do any select query on the dynamic partition table. So I do select. This is my dynamic partition table. And I say where section equal to A. So everything, the result will be the same, whether you use static or dynamic or static file to file or file table to table, all result will be the same. Only way is how different way you can create the partitions. Okay, this is okay. So now dynamically your table is like a loaded the data. So now if you do one command is there, show partitions, you can see show partition, show partitions and table name student 12 underscore dyna underscore part. So it is telling how many partitions are there. So it is not necessarily like only partition you created while creating table, then only is possible, or insert query when you are doing, then only the partition is created. Partition even can add it later also, like suppose alter table, add partition, and then you can specify partition column like section equal to C. Okay. And then you can write the data. Okay. Alter table, add partition. You can select query. So alter table, like you can add a new partition into table name. So logically it will add the partition, a blank partition it will add. Later you can put the data in that partition, or you can insert into table command, you can write the data, you know already that command. So that command you can do. Okay, I think something command is alter table, add partition. So add partition or drop partition, two command are there, add partition, Hive. So if you want to add a partition or you can drop a partition. So alter table, add partition, alter table, add partition, and partition column and value. Okay, you don't need to table. Oh, table second time. Why I'm giving table again? Alter table name. So alter table name. So I missed the table here. Okay, so alter table name. So table name is add partition. Something again problem. Alter table name, add partition, spelling is wrong. Partition. Okay, and then partition column and then partition value. Okay, now I do show partitions. So I will see 3 partitions are there, but there is no data in this partition. So show partitions. See, okay, but if you do the select star from, but there is no data, you have to load the data from the source. Okay, select star from student 12 underscore Dyna underscore part where section equal to C. So same way you can drop partition also. Suppose you want to drop partition. So alter table, drop, alter table, table name, student 12 underscore Dyna underscore part, drop partition, alter table, drop partition. Suppose I drop the section equal to B. Okay, now I do show partitions. But if I do select a star from student, data will be not deleted because logically it deleted partition only where section equal to B. Okay, partition data. So but column section B. Okay, so there is no partition at the data. If I see select star from student, there is a MSCK repair command we have to use. Sometimes data is not deleted. Start from. Okay, so only A partition. So C I have not added. Okay, so there is a partition management is there. We can drop, alter, show partition, copy partition. We can make a new partition like copy partition or rename partition. Suppose this partition name I want to change. So alter table command, right? We can alter, like we can rename partition, we can do. So there are many commands are there. These are the called partition management. Okay, we can do. Okay, so we understood static and dynamic partition. So you guys do practice on this. Okay, so I'm not going on more on this. So first, just do hands-on on the basic, and you can see if you want to go through more. I will share this all the notepad file. So there is different nodes are there. Session 3 complex data type. So one more, this complex data type is like how we can create a array type data, struct type or map type of data. So we have to create this sample data. Then we have to create a table, and then we can write the data into table, and then we can query. This is very simple thing. So if I suppose I have a array data, okay, so I will create a one file, okay, cat greater than array file, okay, and I will add this data. And array, you can see that one column is array name. This sub, the column name is a sub. So sub is a column name. If you see here, like ID is the first column, name is the second column, name is the second column, and the third column is a salary, and then after is a column named sub. And sub column is the field are separated by dollar, and the last column is a city. Okay, the last column is a city. So I created a one array file. My data is like the file I have a data. One column is a array data, and data of array is separated by dollar, and other columns are separated by comma as usual. So what will be my create table syntax? So my create table syntax, when I'm writing a create table syntax, so I will be, first of all, this greater than sign will not come. Okay. So this create table syntax, I will define fields terminated by comma, but here the change is there. Collection items terminated by dollar. So here I'm saying array type as a type of string of array, because my all the values is a array is a string type values. Okay, my values are the string type, and these values I'm defining, I'm separating by the dollar. So when I do create table, so this table I will be going to create in the Hive shell. So I will create this table. Now, next thing what I need to do, I have to load data. So load data local, same way, like I will do data home Arvin slash Hive test slash my file name is array file. Okay. And then into my table name is a tab 7. The table tab 7 and this. Now select, if I do star from tab 7. So you will see the sub column, the square bracket, the data is coming. Suppose I say I want to get the data is ID is same, name is same, Sally is fine. Sally I can take directly SAL, comma, sub, I would say 0 index and sub of 1 index. So if I'm saying sub of 0 and sum of 1, then I will get first index and second index. So A and D is coming from the 0 index, and first index B and F is coming. So I am getting the data. So this is the way to get the array data. So first we need to create a table, load the data into table and create a file, the data you create, and then load the data into by using load data local command. Okay. So this is the complex data type in Hive. Another complex data type is like, okay, struct type is there. Okay, so you can see this example. In this one, all three types are there. So if you see this $B$C is a subtype, which is an array type of string. And another one you can see hash is there. It is a map type. Map type is there, and this map type is key value tier. So DUD. So DUD is a type of map, string comma integer. So PF is a string and value is an integer type. So map has two type is there, like key and value. So both type you are telling. Array is only string type. So one type is coming. And now if you see struct type, I think in this one it is a address is there. Okay. If you see here, address is there. That is a struct type. So city is a address. Like if you see Hyderabad, this is a string type. AP, this is state, this is a string type. But last one is a zip code. This is an integer and it is a big int type. So whatever type of data, if array type is only string type, DUD is a map type. It is having a two data type, string comma int, and struct type has different data types of different values. Okay. So when you are creating this file, okay, the file is a map file. So I'm creating a one file, create map file, which has all three complex data type. Okay. So I will create this and I will create a table with this. So in this table, you will find a difference, right? Array type is already there. Okay. Array type is column item terminated by dollar, but map key terminated by hash, because map data is like your hash separated. Okay. But collection item, even in the map or even in the struct or even in the array, all the different complex data type has collection item terminated by dollar. Okay. But table fields are separated by comma. So you should not mix it, right? You should, whatever your data has the separation of the character. Suppose your comma is not a separation character for the field. You are using suppose pipe. So you have to change here, comma is a pipe. If your collection item is terminated by dollar, but if it's not a dollar, suppose it is a hash sign. So you can change hash. Suppose your map key value pair item is not separated by hash, it is something else, you have to change it. Okay. And now I'm creating a table 11. Okay. I'm going to create a tab 11. And now I do select star from tab 11. Okay. The data is not loaded because I didn't use the load data command. Okay. So load data local in path slash home slash the file location, Hive test, and the file name is a map file, and into table tab 11. Okay, data is loaded. Now I can see all the data. So if you see the data is coming on the array is square bracket, data is coming in the map is braces, but difference is key colon value. But data is in the struct is coming again key colon value. So how will you recognize, right? This is a struct or this is a map. So the easy way is in this map, it is having the key and value. Okay. So key and value is here. Okay. So you have to know from the table, right? If this column is a array type column or this column is the struct type, this column is the map column or this column is a struct column. Okay. So you can have multiple key value pairs separated also, right? But here is you are defining in the struct all different data types will be there, right? Because one is a string to string, string to string. Here is a string and integer, because this is the different data types are there. Suppose you want to take it, select ID, name, and array field name is a sub. You say I want 0. Okay. And suppose struct field is dot operator you do. Your field name is addr. So I say addr city, addr dot state. I want to know state. And if I want to know for pf1 or this one map1, so you have to use similar way of array, only key you pass as a single quote. So my map name is DUD. So DUD in square bracket you will give key name. So my key, I want to find the PF data. Okay. And like this. And another DUD, I want to find EPF. Okay. And then I will say from tab 11. So now you will see here is the array data is coming. Here is struct data, city and state is coming. And here is PF data is coming. But here in the second one is no EPF. That is the reason it is returning null. Okay, so array and map, the difference is here you will be passing the key in the single quote, and here you pass the index, like which index value you want, because all are the same type. Okay, so here you want to pass here the key, because that particular key, it will get you the value of that particular key. Okay, so try this examples, all these examples you try. Okay, and I think your Hive internal table, external table, partitioning, bucketing is not covered, and this complex data type. Okay, I will share the recording and this document. Okay, so you can follow this one and you can practice. Yeah. Okay. So anyone has any question?
So this Hive can be called from Java as well, right?
Hive you can call through Java, right? Means how to call Java means like it's a Java main program. So you can use a driver. You have to use JDBC, ODBC driver. You have to do JDBC connectivity. So generally we use Hive server 2. We use for the JDBC, ODBC connection. Generally Tableau we use, right? If you want to render the data. So programmatic way, that is a programmatic way like Java, Python, any programming language, you can connect Hive, like, and the server is Hive server 2. So there are the two server are there. One is a Hive server that is generally we use, but Hive server 2 is a special, right? That is for the what is called that two different programming language or operating system like you want to. So what is the name is called? Thrift server. So there is a Thrift protocol is there. That is a general protocol. It's not related to Hive. HBase also support Thrift. Hive also support Thrift. HBase Spark also support Thrift. So these all framework of Hadoop Spark are supporting Thrift. So Thrift is a protocol which is using like protocol. This Thrift protocol is means like you are connecting from one cross platform and cross language. Okay, so that purpose we use Thrift. So we can use Hive server 2. Like we can provide a driver, URL, username, password, and connect to JDBC option, like we can connect through Java program. Yeah, and get the tables and that data, everything. Yeah.
Can we export data from Hive?
Yeah, we can export data, right? You can use Hive -e and you can give a SQL query in the $shell, and then you can greater than like you can write into the file. Okay,
Okay.
that way you can export, or you can give some shell command. You can use like connection, and then you can write a data. As export you can do like this way. You can just Hive -e, and you can, yeah. Okay. Yeah. Thanks everyone. Thank you.